All right, a little thing that we saw last week. Let me remind you guys of something that we saw. Question 23, when we subtracted polynomials, right? We saw this last week. You guys should have it on your notes. When we subtract polynomials, then we just change the sign of the second polynomial. Remember 23, like I said, this is a reminder of last week. We write the first term as a 7x squared plus 5x minus 5x to the third. Right? The first polynomial we don't change. It's just the second polynomial. We change the sign of everything. I'm going to go minus 8x squared plus 8x to the third minus 7x. Remember that? Okay, so I'm not going to work this. We worked this last week. I just want us to refresh our mind and say, okay, when I subtract polynomials, I just changed the sign of the second polynomial, okay? Keep that in mind. We're going to use that in a minute, okay? So like I said, I just wanted us to refresh that. For today, I'm going to be working questions 26 through 29. We're going to call this long division. Let me see here. I'm going to divide polynomials. So what I'm going to write, let me write 2m plus 7. And I'm going to divide this into 2m to the third minus 5m squared minus 44m minus 7. Okay, I'm going to divide that. One thing I want us to double check are the exponents. I cannot be skipping any exponents, and they must go in order from large to small. So looking on the outside, like I said, I'm looking at this term right now, 2m plus 7. Right, my first exponent is m to the 1, and then m to the 0. With the 7 is m to the 0. That's why we don't see the m. So my exponents are in order from small to large, and I'm not skipping any. Looking inside of my division house here, I see m to the third, m to the second, m to the 1, and then lastly, m to the 0. Okay, so that's okay. Because I cannot be skipping any exponents. Now, let's say I did not have an m to the second. Let's say I did skip an exponent. Now, I said a few seconds ago, we cannot skip any. But right now, like I said, I'm saying, let's say we didn't have an m to the second. So in that case, I will want you to write plus 0m to the second. Like I said, we cannot skip it. So if we don't have it, you put a 0 for it. In this case, we do have it. We do have an m to the second. So I'm just going to write that as minus 5m to the second. Again, let me say that again. We cannot skip any exponents. If we don't have one, put a 0 for it. So we do have it, but if we don't have it, put a 0. Okay, so I'm going to divide here. First thing I'm going to do, I'm just going to look at the first term here on the outside, which is 2m, and the first term on the inside, 2m to the third. Okay, so I need to figure out what am I going to multiply 2m in order for me to make it 2m to the third. Now think about that. 2m times what? What do I have to multiply 2m by to make it 2m to the third? Like I said, think about it. Okay, so we're thinking. So, all right. So first of all, number wise, 2 don't have to change it. So my number is fine. Letter wise, I have to multiply this by m to the second. Right? M times m to the second, that gives me m to the third. Remember how when we multiply exponents, we just add the exponents? Okay. Now, what I'm going to do, let me multiply m to the second. I'm going to multiply m to the second to my terms out here. Okay. So I have to go m to the second times 2m, that's going to give me 2m to the third. M to the second times 7, that's going to give me positive 7m to the second. Now I'm just going to subtract my exponents. I'm going to subtract, I mean, my polynomials here, just my first two terms. But remember how a few minutes ago I said when we subtract polynomials, we switch the signs of the second polynomial. Remember I said that. When we subtract polynomials, we basically just switch the signs of the second polynomial. So I'm going to say this is negative 2m to the third, and this is negative 7m to the second. All right, on the first one, 2m to the third minus 2m to the third, that gives me 0. This first term will always cancel out. That's what I want, right? 2 minus 2 is 0, so it cancels out. Now this next term, negative 5 and a negative 7, that's going to give me negative 12m to the second. Okay, now let me bring down the next term, minus 44m. And I'm just going to focus on my 2m and my negative 12m squared. I'm just focusing on the first term, just the first term. All right, so I have to make 2m, I have to multiply 2m by something to make it negative 12m squared. Okay, number-wise, I had to multiply by negative 6. Right? Because 2 times a negative 6 will become a negative 12. So number-wise, I have to multiply by negative 6. Letter-wise, m to the 1. Now let me multiply negative 6m times these two terms. Negative 6m times 2m gives me negative 12m squared. Right? Negative 6 times 2 is negative 12. The m's, remember multiplication, you just add the exponents. That's how I got m to the second. And then negative 6m times a positive 7, that's going to give me a negative 42m. So I'm going to subtract my polynomials here. So I'm just going to make this line. I'm going to subtract, but remember we just switched the signs of the second polynomial. So let me switch this to positive 12 and a positive 42. Remember, we just switched the signs of the second polynomial. The beginning here, negative 12m squared plus 12m squared. Negative 12 plus 12, that's 0. So that cancels out. Negative 44m plus 42m, that's a negative 2m. Let me bring down the next term. So negative 2m minus 7. Okay, again, I'm just worried about my 2m with my negative 2m. Number-wise, for 2 to become a negative 2, I had to multiply this by a negative 1. I'm not going to change my m, so I'm just going to multiply this by negative 1. Let me multiply negative 1 times these two terms. So 2m times a negative 1 gives me negative 2m. 7 times a negative 1 gives me a negative 7. And I'm going to subtract these, but remember, I'm just going to switch the signs of my second polynomial. Negative 2m plus 2m cancels out, which is what I wanted. Interesting part here is negative 7 plus 7 is 0, so that also cancels out. My answer here will be m squared minus 6m minus 1. This right here. M squared minus 6m minus 1. Everything cancels out at the end, so I don't have a remainder. Sometimes we will have remainders, but for right now, at least for this first two questions, I don't want us to have remainder. Okay. Okay, so I said the first two questions don't have a remainder, so I expect number 27 to not have a remainder. Let's take a look. The way I'm going to write this will be 7b minus 8. Gonna divide into 35b to the third minus 103b to the second plus 65b plus 8. Again, make sure you're not skipping any exponents, okay? We're not skipping any, so we're good to go. My first thing I take a look at is 7b goes into 35b to the third. Okay, so number-wise, I'm going to multiply 7 times 5. Because 7 times 5 will give me 35. Letter-wise, I'm going to go b to the second, right? Because b times b to the second is b to the third. Now let me multiply the 5b to the second times both of these. Right, 5b squared times 7b gives me 35b to the third. Remember, I just went 7 times 5, and then letter-wise, I add the exponents. 5b squared minus 8 will give me negative 40b squared. Okay. Let me ignore these lines right here. Okay, so now I have to subtract. I'm going to subtract these polynomials. But remember, I must change the signs of the second one. So this is negative 35. This is positive 40. 35b to the cube minus 35b to the cube. 35 minus 35 is 0. I expected that to cancel out, so that's good. Negative 103 plus 40. That gives me a negative 63b to the second. Signs were different, so I subtracted 103 minus 40. Keep the sign of the large one. All right, let me bring the next term down. So plus 65b. I'm just looking at 7b. I have to make it into negative 63b squared. So number-wise, in order for 7 to become negative 63, I have to multiply this by a negative 9, right? 7 times a negative 9 is 63. Letter-wise, b times b will give me b squared. Okay, so now let's multiply negative 9b times this 2. So that's going to give me negative 63b to the second plus 72b. Let me draw the line because I'm going to subtract. But I know for subtraction, I have to change the signs of my second polynomial. Let me erase those lines. All right, negative 63b squared plus 63b squared. I expect that this to cancel out. Now, positive 65 minus 72b. Signs are different, so I have to subtract, keep the sign of the large one. Let me call this a negative 7b. Let me bring down the next term, so plus 8. I'm looking at my 7b, and I have to make it into a negative 7b. So I must multiply this by a negative 1. Negative 1 times 7b is negative 7b. Negative 1 times a negative 8 is a positive 8. I'm going to subtract this, but I know for subtraction, I change the signs of the second polynomial. So this is positive, this is negative. 7 minus 7, this cancels out. But here, positive 8 and a negative 8, this also cancels out. So I don't have a remainder. Everything cancels out at the end, which is what I was expecting. Remember 26, 27, I said no remainder. My answer will be here. 5b squared minus 9b minus 1. I know some of you guys might be thinking, oh man, this is long work. That's why it's called long division. Okay? So you guys might be like, oh, this is a lot of work. Again, that's why it's called long division. All right, let me open up some room here for me. All right. Now, questions 28 and 29, things are going to change a little. The only difference is going to happen is that I will have a remainder, okay? So I didn't have remainders on 26 and 27, but I will have remainders for 28, 29. So let me write this thing out. I'm going to go 10v minus 4. Oops. Is going to go into 50 v to the third plus 80 v to the second plus 20v minus 19. Okay. Again, I'm just going to look at my first term on the outside and my first term on the inside. Right. I also did take a look that I was not skipping any exponents, neither outside nor inside. So everything is fine. All right. So I had to make 10v. I had to make it 50v to the third. So number-wise, for 10 to become 50, I'm going to multiply this by 5. Letter-wise, I'm going to multiply 10v times 5v to the second. Because remember, letters, I just add the exponents. So v times v squared becomes v to the third. Okay, so let me multiply this 2 out. 5v squared times 10v gives me 50v to the third. 5v squared times a negative 4 gives me a negative 20v squared. And I'm going to subtract. So let me ignore this line for right now. I'm going to subtract these two polynomials, right? The first two terms. But I remember, when I subtract polynomials, I must change the signs of the second polynomial. So this is negative 50. This is positive 20. 50 minus 50, right? When it comes to v to the third, 50 minus 50 is 0. So that cancels out. That 80 plus 20, that's 100 v to the second plus 20v. Notice I just dropped the next term. So then I'm looking on the outside, 10v, I must multiply it to make it 100v squared. So number-wise, for 10 to become 100, I must multiply this by 10, right? Because 10 times 10 will give me 100. Letter-wise, v times v will give me v squared. So now let me multiply it, 10v times this terms. All right, 10v times 10v is 100v squared. 10v times a negative 4, that's a negative 40v. Okay, let me ignore those lines. I'm going to subtract these two polynomials. And I know when I subtract, I change the sign of the second polynomial. So let's change this to minus 100 plus 40. All right, 100v squared minus 100v squared, they cancel out, which is what I wanted. 20v plus 40v gives me 60v minus 19. Okay. So I'm looking at my 10v with my 60v. Number-wise, 10, I have to multiply this by 6, right? 10 times 6 will give me 60. Letter-wise, I already have a v, so I'm not going to go another v. Let me multiply this 6 to this terms on the outside. So 6 times 10v is 60v. 6 times a negative 4 is a negative 24. Let me draw my line, and I have to switch my sign. So this is negative 60. This is positive 24. I expected my 60V minus 60V to cancel out, but negative 19 plus 24 doesn't cancel out. Negative 19 plus 24, it's actually positive 5. Now, I don't have any more terms to bring down, right? I don't have anything else to bring down. So that positive 5, it's a remainder. I know you guys learned back in probably middle school or elementary how to write remainders. You guys wrote it as a fraction, right? The remainder is a positive 5. So let me write plus, because it's a positive. I'm going to write a fraction and then a 5 on the top. If my remainder was a negative, I would have done a minus in front of the fraction. But again, I put my 5 on top of the fraction because that's my remainder. Now, at the bottom of the fraction, I'm going to write 10v minus 4. Now, some of you guys might be wondering, where did I get the 10v minus 4? Right here. Now, that's it. Now, 26 and 27 did not have a remainder. 28 and 29 will have a remainder. Our remainder, we write it as a fraction. Okay, let's take a look at number 29. Let me write 3n plus 2 is going to divide into 3n to the third minus 4n squared plus 11n plus 15. Double check that outside and inside, I'm not skipping any exponents. All right, I'm not skipping any in this case, but double check on that. And I'm looking at 3n and 3n to the third. Number-wise, nothing I have to do, right? 3 is 3, so I don't have to change my letters. Letter-wise, I have to multiply the top by n to the second, right? N times n to the second is n to the third. So let me multiply this out. 3n times n to the second is 3n to the third plus 2n to the second. And I multiply that out. Let me ignore this. I'm going to subtract those two polynomials. And I know when I subtract polynomials, I basically switch the sign of the second polynomial. So this is negative 3. This is negative 2. Here, 3 minus 3 cancels out at the very beginning, which is what I wanted. Negative 4 and a negative 2, that's going to give me negative 6n to the second plus 11n. Notice I just brought the next term down. All right, so I have to multiply 3n to make it negative 6n squared. Number-wise, for 3 to become a negative 6, I have to multiply this by a negative 2. Right, 3 times a negative 2 will become a negative 6. And then n, because n times n will give me n squared. Now let me multiply this negative 2n across. Negative 2n times 3n, that's going to give me negative 6n squared. Negative 2n times the 2 is going to give me negative 4n. And I'm going to subtract these two polynomials. Okay, let me erase this line. Now I know when I subtract polynomials, I change the sign of the second polynomial. Negative 6 plus 6 is 0, so that cancels out. 11 plus 4 is 15, so I'm going to call this 15n plus 15. Notice I brought the next term down. All right, so I have to multiply 3n to make it 15n. So number-wise, for 3 to become 15, I have to multiply this by 5. Letter-wise, I'm okay. I already have the n. Let me multiply the 5 times 3n and then 5 times 2. So that's going to give me 15n plus 10. I'm going to subtract my polynomials, but I know in subtraction, I change the sign of the second polynomial, so that's going to be negative 15, negative 10. 15 minus 15 is 0, so that's good. Now 15 minus 10 is a positive 5. I do have a remainder, right? Not everything cancels out at the end. It's a positive, so I'm going to write plus a fraction. I'm going to write my 5 on the top. My remainder goes on top. And at the bottom of my fraction, I'm going to write 3n plus 2. Again, that comes from right here. Let me zoom out. Again, if you're thinking, oh man, this is long work. Again, that's what we call this long division. Right? This is not short division, it's long division. So there you go.